Today I'm going to be talking about algebraic properties, and these are going to lead into algebraic proofs. And before we can do algebraic proofs, we have to remind ourselves of the properties that we can do when solving an algebra problem, and then we're going to practice identifying them. So the first four that you should be very familiar with is the properties of equality: addition, subtraction, multiplication, and division. And these are all properties of equality. So if we have an equation, let's say something like 3x minus 1 equals 5. Well, the first step we would do to solve for x is we would add the 1 to both sides. So whatever operation we do, that is our property. So since we're adding 1 to both sides, that is our addition property of equality. Let's do the next one. Let's say we have something like 3x plus 1 equals 5. Well, so for this one, since we have a positive 1, we would subtract 1 on both sides to start solving for x, and that is our subtraction property of equality. Now the next one might not be as familiar, but let's say we have a fraction like 1/4 x plus 2 equals 7. Well, whenever we have a fraction, to get rid of that fraction, we multiply everything by the denominator. And when we do that, that is our multiplication property of equality. So whenever we start with a fraction, it's good to get rid of it using multiplication. And our last one right here, let's say we have something like 5x equals 10. To get the x by itself, we would divide by 5 on both sides. And so that is our division property of equality. Now these next ones, probably you've never heard of them or they're not as familiar. But this next one is the reflexive property of equality. And the way I think of it is if you look in a mirror, you see yourself, your reflection. It's kind of the same for algebra. If we have 5, it will equal 5. If we have x, it will equal x. It equals itself. Now we don't use this property very often in the algebraic proofs, but we do see it a lot in the geometric proofs. Now the next one is the symmetric property of equality, and it says if A equals B, then B equals A. And if you notice that we flip this, we just flipped it. So if we see a flip, that is the symmetric property of equality. Now for number 7, I'm going to go back and talk about the law of syllogism. If we remember the law of syllogism, we have two statements, and we cross out whatever is repeated in both of those statements, and then we get a brand new statement with whatever's left over. This is the same in the transitive property of equality. It says if A equals B and B equals C, and we notice that the B is repeated, so we can cancel those out, and we're left over with A equals C. So the transitive property is when we cancel out what's the same, and then we have what's left over, A equals C. Now the substitution property of equality is a little tricky to identify, but you know how to do it. That's what we call plugging something in. So let's say we have something like y equals 3x plus 1. And then I tell you x equals 2. Well, you know that we can plug the 2 in for x, or substitute it in. So y equals 3 times 2 plus 1. So that is our substitution property of equality. We're substituting in something for something else. Okay? And our last two properties, they're not properties of equality, they're just regular properties. The first one is the distribution property. And we can use this when we see something like 2 times the quantity of x plus 1. Whenever we see those parentheses, we usually think, oh, distribute. So that we're going to do exactly that. We distribute, and we get the 2x plus 2. And so we can say that we use the distribution property for that. And our very last one that I'm going to talk about is simplify. So say we have something like 2x plus 1 plus 3x equals 10. Well, when we look at this equation, the first thing that we are going to do is we are going to combine like terms. So when we do that, when we combine like terms, in our proof, we use the word simplify. So it's another word for combining like terms, simplify. Okay, so when we combine like terms, we write down simplify in our proof, and you'll be able to see that in tomorrow's lesson. So now what I'm going to do is I'm going to go through and we're going to practice identifying these properties. What we're going to do is we're going to look at statement 1 and see what happens to get to statement 2. Well, let's look at this first one, x minus 9 equals 7. What we need to do to solve for x is to add 9. And 7 plus 9 is 16, so that's what they've done. So we've used the addition property of equality. Okay. Next up, if we look at this, to solve for x, we would divide. And 14 divided by 2 is 7. So this is the division property of equality. And you must have that property of equality at the end because we are going to be talking about other properties later on. And next, we see those parentheses, so we should think distribute. So we're going to use the distribution property. And remember, this one does not have equality on it. This is special. It does not have equality. It's just the distribution property. Next up, we have a fraction, and whenever we see a fraction, we're going to multiply to get rid of that fraction. So this one is the multiplication property of equality. All right, and this last one at the bottom, to solve for x, we would subtract. So this is our subtraction property of equality. Okay. And I have one more slide for you of some more practice. Okay, so if we look from statement 1 to statement 2, we have A equals B and B equals A. If we notice, that's just been flipped. And whenever we have a flip, that's our symmetric property of equality. All right, this next one, we have x equals y and y equals z. Then in statement 2, it says x equals z. If we notice that we cancel out the y and we have left over x and z, that's our transitive property of equality. All right, next up, we have x equals y. And then I tell you 2y plus 1 equals z. And then we get to 2x plus 1 equals z. If we notice what's changed is that the y has been replaced with x, or substituted. And that's our substitution property of equality. This next one, to solve for y, all we have to do is divide by 3, and we get our division property of equality. And our very last one, we see parentheses, so we're going to distribute, so that's our distribution property.